So today we've got a little baby oscilloscope on the bench. This is actually a BK Precision 1420. It's a little 15 megahertz oscilloscope, dual channel. I don't think it's dual trace, but it is a dual channel. There is an A and a B. I'm not exactly sure if you can turn them both on. I haven't read the manual on this. In fact, I'm having a lot of trouble finding a manual or any information on this at all. But I got it, and I bought it with a complaint of no power on. So I figured first thing we do is let's see if we get some power. Go ahead and plug it in. And it uses a little regular computer adapter. I'm not sure if this is the original adapter. This is Asian Power Devices. But let's go ahead and plug it in. Now these little scopes are considered portable, so they can actually use a battery pack. This one did not come with a battery, and if we get it working, I'm probably not going to put a battery in it anyways. Alright, let's see. It is actually on right now. The intensity knob is actually what clicks it on. And there's no red light, there's no trace, and there's nothing to tell us it's turning on. I'm also testing out a new microphone. It's actually a USB microphone. I'm trying to get my audio a little bit better, but I don't trust it yet. It's actually right here in the corner. You can see it in the screen. But I am recording backup on the camera itself, just in case. Alright, so we should be seeing what should we be seeing here? Hang on. 0.65 amps max. Output 12 volt DC 2 amps. Okay. So we're seeing just slightly under 12. I think that is going to be acceptable, which means that we don't have a power supply issue, at least not an external power supply issue. Alright, let's go ahead and take this thing apart. There's a lot of screws on this thing. Let's give it the old smell test. No burnt components, but I do, wow. I see something that y'all are gonna want to see. Alright, so we've got a pair of fuses in here that both look like they use the same footprint, but this one is a little bitty tiny thing and it's really loose and just flicking around in there, and this one is a giant compared to it that doesn't even look like it's really grabbing properly. So could it be that we just have a fuse issue? Also, be very careful if you're going to use pliers to pull fuses out. I'm going to grab it by this metal top here. Okay, that fuse looks good, so let me see if I can grab this one by the metal too. Yep. Okay. So, two totally different fuses that they don't look bad, but they definitely aren't right. Okay, so those fuses may have been good, and we may just have a no contact issue here that might be not letting power get through, but they're obviously not the stock fuses, and most people don't just go replacing fuses with the wrong fuses just on a will and a whim. So I really think there might have been a deeper issue in here that would have blown those fuses. And I think the best course of action now is to actually, because number one, I don't have the correct fuses in stock either, but I also don't want to put fuses in there, blow them up, and then be back at square one. So I'm actually going to short the fuse connections. I'm going to put jumper wires on it, and then we're going to power it, and we're going to power it through the external power supply, the same plug that we were using from the wall, that same adapter, well actually that same receptacle here, but we're going to power it from an external current limited power supply so that we can ramp it up nice and slow, and we can see if there's a dead short in there somewheres. And this is the supply I'm going to use. This is the Raycall Dana 9232. I think 30 volt 2 amp power supply should be plenty enough for what we want to do. Alright, I've got the power supply set to 12.14 volts, and the current limit right now is at about 0.8 amps, which I think will be kind of conservative, but we'll wind it up slow and see what we get. Okay, the power supply is on, and we do get a red LED. I am bumping the current limit. Let's turn that up a little and see. I feel like as long as we're under 2 amps, we'll be okay. Oh, there we go. So it's drawing about 1200 milliamps, just a little bit under 1200 milliamps. I don't think that's anything dangerous, but we've got an indicator light. You also have to be very careful with these CRT units, because they do produce a very high voltage to power that CRT. So let's just gently tilt this and try to get it to where you can see. But we don't have any sort of a trace at all. We do need to check and see if we can check our calibration wave. Oh, what was that? Huh. I can see if I kind of play with this a little bit, I do get a little bit of a trace. Let me see if it does that on. So there's something there. Let's input a waveform and see what we get. Oh, wait a minute. I can see a waveform, but only whenever I change it, it shows up for just a split second. Let me try turn off some lights here and see if we can't get the camera to pick it up. Oh, there we go. But you can very clearly see the square wave, which should be the wave that is coming from the calibration. In fact, let's turn the Raycall on. Let's turn some lights back on too here, people. Alright, let's just double check our calibration waveform to make sure that it's a good clean wave. Go, man. We were out there in Timbuktu on this thing. So we are getting a really good waveform. So I don't know what direction that's really going to point me in just yet. tell you what, why don't we try the most basic thing, and we'll unplug the scope and we'll clean the contacts really good. We may have some oxidation or some residue built up on the contacts that it only gets a good contact every once in a while. Oh, by the way, quick shout out to Rigol, because when I bought this scope, it was missing like 3 of the knobs, and then 2 of them were broken or something. But they were in really bad shape, and it was real difficult to use the scope. And no matter what other knobs I tried to get off the shelf, they just didn't seem right on it. So I emailed them, and they actually sent me a set of knobs. They don't sell them anymore, but the guy actually went out into the shop and found a set, bagged them up, and sent them to me for free. So awesome customer service from Rigol. Alright, so let's get to work cleaning these contacts. Now, to clean them, I'm going to use this Electrosolve contact cleaner. This is from MG Chemicals. This is for electronics. And I really like this stuff. It works really, really well. Leaves like no residue. Just a little bit of cleanup after with isopropyl alcohol is what I normally do. But to use it, it's pretty straightforward. Of course, whenever you're using any kind of aerosol, you want to be really careful of any splashback getting into your eye. So, you know, wear eye protection, things like that. But it's really straightforward. What I'm going to do is actually kind of support the scope a little bit because I don't want it to fall over on me. And anywhere we can get this solvent in a contact we want to get into. So we know that we have a little button here, so let's go in the top here. And you want to be pretty generous with it. And as you're, you know, while the contact cleaner is actually still wet in there, you want to kind of work that contact. That way it moves that liquid around everywhere is in there and will help just dissolve everything and also kind of flush it out a little bit. And then over here we've got some switches. We may, right now I've got the scope face down so that gravity kind of pulls it into these range switches here. These little rotary switches. But you just want to be real kind of aggressive with it. You know, you're not going to hurt anything in there by spraying this. So, you know, just really kind of flood it. And you really want to try to get into all those little nooks and crannies, because for some reason that's where things like to build up and problems like to happen. We got our switches here we're going to go ahead and get to. Let's go ahead and put the scope face down. You can see I'm kind of flooding the bench with this stuff. Wow, those switches already really just kind of loosened up. They were almost impossible. This one's still a little tight. Let's see if we can get it going a little bit. A little better, yeah. We want to work those range switches. We want to kind of try to get some more solvent in there. And even spraying it on the shaft that goes into the switch and turning it and letting it kind of just creep in there helps. But yeah, that's the secret of this stuff, is to be generous with it. And then a little cleanup with some 99% isopropyl alcohol. Once again, be generous. We're just kind of trying to flush out any little contaminants in there. Alright, that's pretty much all there is to it. Okay, so we've got it all sprayed out. Let's go ahead and plug it in and see what happens. I've also let it dry a little while. No, we're still only getting those little microsecond glimpses. But we are getting it more consistently. And it's only whenever we go to the 2 millisecond sweep time. Let's kind of okay, so that really has no help to us. Alright, so we're only getting a trace whenever we drop our time base from 1 millisecond per division to 2. It's doing it very, very consistently though. So I feel like if it would have been bad contacts, we wouldn't have such a consistent issue. It'd be a little bit more spotty. I think our next step is to break out the Esr meter because there's some electrolytic caps on this board that I think we need to check out. So let's go ahead and turn this off. Since cleaning the contacts didn't really seem to fix the issue, although I do find that it helped a little bit. I found that it kind of gave a little bit more of a sharper trace. Before it seemed like it was a little bit more kind of just scattered across the screen. But since that didn't completely fix the issue, I went ahead and actually kind of loosened up the horizontal board. On an oscilloscope, you'll have a vertical board and a horizontal board, or you'll have a section which is vertical and a section which is horizontal. But I find most of the time they do typically break them up into 2 different boards. And this board on the bottom is actually our power supply board. And we know that because there's a transformer there, there's some pretty big bulk caps, and there's some voltage regulators. We know that this board is our vertical board because it has our volts for divisions on it. They're sorted on. And this is our horizontal, or our time base, because it has our sweep time per division adjuster on it right here, the range switch. And the reason they call them vertical and horizontal is because you measure your volts by the vertical movement of the trace. So the taller it is, the higher the voltage, the lower it is by the reference point. And your horizontal is your time, so it's going to move along. The longer it moves along, the longer it takes. That's horizontal movement. So anyways, I've got it loosened up. I don't have it removed all the way because that would require me taking off a whole bunch of stuff that I don't think I need to take off right now. This is just to give me a little bit better access. And I also went ahead and pulled out my Esr meter. Now for those of you who have never messed with an Esr meter before, very basically what it does is it'll insert a 100 kilohertz waveform. I believe that this one actually is a square wave. You can do this in circuit. You put your leads on the capacitor and it injects that square wave into it, and it will actually measure the voltage drop across that square wave. So what equivalent series resistance is basically anytime you have a capacitor, this is especially true for electrolytics, in a circuit, you don't strictly have capacitance through that component. You also have a certain amount of resistance. and you can't measure that resistance with an ohm meter. It just doesn't work. You'll have to go way deeper into, you know, how capacitors work to learn why. That's not what this video is about. And you can do this in circuit. They do say it's more accurate to take it out of circuit, but I'm just gonna go around checking and seeing on my horizontal board if there's any that look like they're very bad. Okay, so to use the Esr meter, the first thing we do is turn it on. And once we've got it on, short the leads and zero it out. And we'll also make sure this one you can do auto range or manual range. So we'll kind of go through here and get it into auto range, I think. There we go. And we'll find our first capacitor. Now this is a 1 microfarad 50 volt capacitor. And an ESR meter is not polarity sensitive. And I don't know if you can see it on the screen, but we have 12.5 ohms of ESR. There's also a little chart here that you can kind of follow along that tells you what the ESR should be. But I really feel like that's very, very high. And I actually have, in my parts bin, I pulled this is also a 1 microfarad 50 volt capacitor. So let's just try this one on for reference. Yeah, so we can see that this one has a much lower ESR, but we'll check a few more before we change that one in particular. There's another 50 volt 1 microfarad right below it. It looks like that'll be these two pads here. That one's also very high, 12.7. So we'll go ahead and change those two out. We may end up totally recapping this board. In fact, we may end up recapping the power supply board too, but we'll concentrate on the horizontal board for now. So this is a 25 volt 4.7 microfarad. I'm moving around a little bit so we're not getting the 5.14. You know, that might be okay. These are going to be the same thing. 4.7, 25 volts. It's 4. It's about 4 too. So that those may be okay. It seems like they're very consistent. So they're either all consistently bad or still good. Okay, so I think we'll go ahead and start changing out these caps just to pretty much just to say we did. I'm still not totally convinced on whether or not they're the problem, but the ESR, especially on these 50 volt ones, seems very high to me. I kind of prefer wicking these pads as opposed to getting the vacuum gun out and stuff like that. I just find that the wicking is a little bit more convenient for me, especially whenever I'm doing like just boards that kind of flap around a little bit. And this Super Wick is some really good stuff. One of the keys to really being able to wick solder really well is to either have a wick that has a flux built into it already, or using flux. And this one already has the flux in it, so it just makes it that much easier. Come on, get out. There we go. I'm using 032 solder. What is that in millimeters? I don't know. And I know that that's probably a little thicker than a lot of people think is good for doing a lot of solder work. But I've always found that the thicker stuff, especially for SMD, has just always worked better for me. The thinner stuff, I find that I've got to put 4 inches of thin solder into one joint. And the thicker stuff, it's just a little daub and you're done. Okay, so I think I'll go through my parts and see if I have all the capacitors to go ahead and recap this whole board. I'm not gonna make y'all sit here and watch all that. So when you come back, you'll see a fully recapped board. I'll stab it back together, solder the couple of wires I had to disconnect to move the board, and hopefully we'll see a good trace. Alright, so we've recapped the horizontal board, and I've got it all put back together. I don't have the case on it yet because I'm still running it from an external power supply, and I've still got the fuses jump. We may talk about this later on, what my plan is with the fuses, but let's go ahead and turn the power supply on. I already got the scope on, and we've got a red light. I have the Rigol set up to show I'm just inputting a little sweep frequency in there so that we can see if it's working or not. So let's turn that time base up some. Oh, wait a minute. I see something there. Let's adjust this position a little bit, maybe. It may not be possible for y'all to see. Let me turn the intensity up and see if we can get this showing up. There we go. So we do have a trace, and more than having a trace, we actually have a waveform, and everything looks good. Oddly enough, it doesn't seem to be exactly matching what the Rigol is doing. And now it looks okay. I mean, obviously the waveform is there, but we're on, what are we on here? 50 microseconds per division. So let's bring the Rigol up to 50 microseconds per division, and they're each on 2 volts per division. But you can see that the waveforms look much different. They are sweeping back and forth and everything looks okay, but that's just kind of odd to me. Could it be possibly maybe just because the Rigol screen is different? I don't know. But it is working. It may just be that this scope needs calibration. Okay, let's go ahead and plug it in using the regular power supply. We do have our red light. It takes a minute for these CRTs to warm up. course, it should already be warm. Oh, what was that? Look at this. Our power indicator is actually blinking. So that's interesting. It seems like our little plug-in power supply here could either be broken or it could be not enough. But I mean, it's a 12 volt DC 2 amp. It does feel a little warm. So I'm just wondering if we don't have a power supply problem too. Because I mean, it runs just fine off the external supply. So if our power supply isn't working or isn't working well, because I was getting slightly under 12 volts out of it before, that kind of gives us another opportunity to work with this thing. So I was looking online for power supplies to maybe drop into the oscilloscope, and the more I looked into things and the more I thought about it, you know, it just didn't make sense to me to not try to actually repair the external power supply that I already have, because I knew whenever I broke it open it would be a switch mode power supply. There's not a lot of components to these things, so normally they can be pretty simple and straightforward to repair. So with that in mind, I went outside and I actually went to the bench vise and literally cracked this thing open. They pretty much just glue them together in these little cases. Some of them, the higher quality ones, are screwed, but the higher quality ones also don't break as much. So broke the case open, and this is actually what the power supply looks like on the inside. Okay, so here's a closer view of this little switch mode power supply, and right away, just looking at it, my eyes are kind of drawn to these capacitors because the top is kind of domed up on both of them, and I don't see any electrolytic leaking out. But normally whenever you see that dome top, that's a good sign that they're kind of dried out and that they're starting to get hot and they're starting to kind of expand a little bit. Now there's only there's 3 other capacitors. There's one here, but we're not really worried about that one. That one's a little ceramic, I believe. There's 2 other electrolytics here. There's one here and one here. This little one, it's a 47 microfarad. It doesn't look like it's bulging, but it also doesn't look like it's a vented cap like the other ones are. So they don't tend to bulge out the top. They can actually begin leaking out of the bottom if they get really bad. That doesn't look apparent here, so we'll get out the Esr meter and check this one. These 2 aren't really worth checking. The bulk capacitor on here, which I think is just there to just kind of remove some of the ripple, because switch mode power supplies do produce a lot of ripple, and we'll kind of go into that in a little bit. But these bulk capacitors rarely go out. We'll go ahead and check the ESR on it while we've got the meter out. But these 2 are definitely getting replaced, and more than likely we'll probably just go ahead and replace this one. Okay, so this is going to be that 47 mic. Let's see if we can grab it. Ooh, 2 ohms. That's kind of high to me. I think we'll go ahead and replace that. Let's check the little chart just to see. Yeah, even the chart says 1.2 should be about what it needs to be, and it's way worse than that. Let's go ahead and check one of these bad capacitors just to see what it looks like. Wow, 32.9. That is insanely high. But we're not going to check the other one. But that is definitely bad. Let's go ahead and check the bulk capacitor just to see. Yeah, 0.385. I'm not going to worry about that. I think that's going to be perfectly fine. I think the reason the bulk capacitors tend to stay better longer is that, number one, they're normally rated fairly far over what they're designed to handle. And number two, they're just a massive cap. So there's just a larger volume of that electrolytic that's in there So it physically is going to take longer for that to degrade because it is a larger volume. Any electronics engineers out there that want to go into further detail, feel free to drop some comments in the bottom. So I think we'll go ahead and whip these two off, and this one too. I don't have any 47 microfarads, so I'm going to go ahead and actually upsize it to this 100 microfarad 50 volt. It's a little bit bigger body, but looking at the board spacing actually looks like it should have been a bigger body in the first place. So I don't think 100 microfarads is going to be too much. You can actually see that lead spacing is just perfect. They have a tendency to be very generous with this silicone stuff they put in these switch mode power supplies, but it normally breaks up fairly easily. We've got the capacitors replaced. I've got the cord plugged in, not into the wall yet. We don't have it plugged into the wall yet. But let's go ahead and plug it in, and first we'll check the voltages coming out of the end here. See where we're at with that. And if everything looks good, we'll plug it into the scope. So here we go. 12.03. If I remember correctly, whenever I first checked it, I want to say that I had somewheres around like 11.4 or something like that. So we actually did pick up a volt. So we did change something for the better. Let's go ahead and get the scope and plug it in and see what happens. Okay, so we've got the power supply plugged into the scope. Let's go ahead and turn it on and see what happens. Nothing right now, but we do need to hook up. Let's hook up a wave here. Oh, we got a sweep. Oh, we've got some noise coming from our leads here. I can see something. There it is. Okay, so it looks like the power supply is actually functioning now. So I'm gonna go ahead and order fuses because I'm still jumping right here. Those fuses are actually pretty hard to find, but I did find some, and I'll get them ordered. But let's go ahead and talk a little bit more about this power supply and what I would like to do with it. We'll go ahead and unplug everything. So my hope with this power supply, what I would kind of like to do with it, is to actually get rid of this adapter here. And once I've kind of cleared this way out, I would want to actually cut a groove that this receptacle could actually slide down into, because it has these it has a little groove on its own that it can actually drop into, and I could hot glue it to where it wouldn't want to move. And then the power supply, I'm thinking I can actually put it back in the case just to allow some electrical insulation there, and the case would fit perfectly in here, and I could put a little bit of hot glue just to kind of hold that in. And I think that would actually be a really clean little way to do this, because I would only have 110 power coming out, and then I could actually get rid of all of this wire and just have wires going directly into the board. One of the considerations you always have to bear in mind whenever you're messing with oscilloscopes is introducing noise into it unintentionally. And that's the main thing I'm worried about with my idea about using this switch mode power supply, is that they're very, very noisy. And we can demonstrate that right here with the Rigol. I don't have anything. This is just the open end of my lead of my probe here that I'm just going to use basically as an antenna. And if we probe around, oh, we need to plug it in first. The power supply, that is. Okay. So if I probe around here, we can see that especially around this high frequency transformer, there's just an insane amount of noise. And we don't want to introduce that noise to where the oscilloscope can pick it up. We want to have it as quiet as possible in here. Now, the only way that I know of to reduce this noise is to actually shield the oscilloscope from it. So we'll recheck it. What I want to do is put the power supply back in the case, and we'll slide the case into this opening here, and then we'll actually check noise inside of the oscilloscope's, you know, main body, just to see if the power supply being this close to the scope is going to end up giving us issues or not. Okay, so we've got the power supply installed, for lack of a better word, and it's plugged in, it's powered up. And we're gonna just see if we pick up any noise here. And now I can see, I do see some. You can kind of see that same signal, which I think we can, let's see if we can get in there and measure that. So yeah, it's about a 400 millivolt peak-to-peak signal. That seems pretty high to me. And then there is some serious noise, it looks like, right here. We kind of track that down. So, I mean, the question just kind of comes in, you know, is it the kind of noise that's going to bother this scope or not? And really, 15 megahertz scope, I don't think it really will. It's not the greatest scope in the world. I don't think it's going to be really used for anything extraordinary. Let's go ahead and plug it in and actually see. I'm just kind of searching around to see if I can find any noise. Well, you know, we do know that we are looking for a 400 millivolt signal. So let's see, that's 100 millivolts. So let's go to, that's 200 millivolts per division. So we'll be looking for about 2 divisions high. And let's kind of go through the frequencies and see what we can find here. No, I'm not seeing any noise being introduced just kind of by itself. Let's see if we can pull something in with a probe, possibly. Oh, wow. So the Rigol probe has this sheath on it, and it won't fit on there. Dang, that's a... I don't see any signals there, so it may actually be okay. It is actually a little distance away from the horizontal and vertical boards, so you know, I don't see this scope as being that critical of an instrument that would matter. So I think I am going to end up doing that, and I'll once I have it all done and completed, I'll maybe do a little bit of a follow-up so you can see what it came out to be. But I am going to order the fuses, so I have to wait for those to come in. So for now, I think we'll go ahead and close out of this video. Thanks for watching, guys, and I'll see you next time.